In the race to build more powerful AI, the strategy for a long time has been pretty simple. Just go bigger. More data, more parameters, more computing power. But what if the real key to unlocking that next level of AI reasoning isn't about thinking longer, but about thinking smarter? Let's dive in and break down exactly what that means.
So right now, a lot of the most advanced AI models get better at reasoning by just extending what's called a chain of thought. And what that really is, it's just a long internal monologue where the AI tries to work through a problem step by step. And that's the whole thinking longer approach.
And look, thinking longer has definitely pushed the field forward, for sure. But it has a really fundamental problem. See, when you're dealing with super complex tasks, a longer monologue just gives the AI more chances to make a tiny mistake, a little error that can totally derail the entire chain of thought. It's basically just talking to itself in a bubble, with no real way to check its work against the real world.
And that's where this shift to thinking smarter comes in. Instead of just relying on that internal monologue, what if an AI could actively use tools, like a Python code interpreter, to actually test its ideas, calculate results, and get real feedback from an outside source? It stops just thinking and starts doing.
This brings us to a brand new model from Microsoft Research that's built from the ground up on this smarter principle. Let's meet the rStar2-Agent.
So this is it, the rStar2-Agent. Now the first thing you'll notice is that it's only 14 billion parameters. In a world of AI heavyweights that are often dozens of times larger, this thing is a relative lightweight. But don't let that fool you. It was designed specifically to take on the giants. And wow, this one graph from the paper tells the whole story. Let's break it down. On the vertical axis, you've got accuracy on a really tough math reasoning benchmark. And on the bottom, you have the number of training steps. Now, that green line, that's our little 14 billion parameter rStar2-Agent. Just look how quickly it rockets upwards, hitting over 80% accuracy in just 510 training steps. Now, see the purple line? That's a massive 671 billion parameter model. It takes thousands of steps just to get going, and its best performance barely even cracks 70%. It's an incredible difference.
So, the big question is, how did they do it? What's the secret sauce here that lets this smaller model learn so incredibly efficiently and punch so far above its weight class? Well, the core idea is something called agentic reinforcement learning. So instead of just feeding the model correct answers over and over, you actually let it experiment. It tries to solve a problem by writing and running code. Then it sees the output, whether that's the right number or just an error message, and it gets a reward if its final answer was correct. It literally learns by doing.
And this all works in a kind of loop. So in the first step, the model thinks about the problem and writes a piece of code to try and solve it. Then it actually executes that code. In the next step, it looks at the result it got back, and it thinks about it. Was that what I expected? Was there an error? And based on that real-world feedback, it reasons again, repeating that cycle until it's actually confident that it has the right final answer.
Okay, but here's the really crucial problem that the researchers had to solve. See, standard reinforcement learning, it only rewards the correct final answer. And what that means is a model could write totally messy code, full of errors, stumble around, but if it just happens to accidentally land on the right answer at the very end, it gets the full reward. It ends up learning really terrible habits.
And you can see that exact effect right here in these two graphs from the paper. They're plotting the error rate when the AI tries to use its coding tool. On the left, using a standard training method, the error rate kind of flatlines around 10%. It just stops getting better at writing clean code. But now look at the chart on the right. That's their new method. The error rate just keeps dropping and dropping, heading towards almost zero. This is the proof. This is how they taught the AI not just to be right, but to be clean and efficient in its process.
The innovation that makes all this possible is called GRPO-ROC. Now yeah, I know, it's a mouthful, but the really important part to remember is that last bit, resample on correct. It's basically a really clever filtering method that forces the AI to learn from its absolute best attempts, not just any random attempt that somehow worked. So here's how it works. For every single problem, the AI generates a whole bunch of potential solutions. Then, the trainer filters them. For all the solutions that actually got the right answer, it throws out the messy ones, the ones with lots of errors, and it only keeps the most elegant, efficient, and error-free paths. And for the incorrect solutions, it keeps a really diverse sample so the AI can learn from a wide range of mistakes. It's kind of like a student focusing on their A+ work while still making sure to review all their wrong answers to see where they went wrong. So, this intense focus on the quality of the solution, not just on getting the right answer, leads to some truly remarkable results.
Let's just look at the head-to-head numbers from the paper. On the AMY24 math benchmark, the 14 billion parameter rStar2-Agent scores an 80.6. That's a full point higher than both OpenAI's powerful o3 Mini and DeepSeek R1, a model that is more than 40 times its size. I mean, that is a huge win for efficiency.
And it gets even better. This chart shows the average length of the AI's response during training. The purple line is the standard method. As it learns, its reasoning actually gets longer and more convoluted. But look at the green line. That's our smarter method. It achieves a higher accuracy like we saw before, but it does it with a response that is way shorter and more efficient. It's not just thinking smarter, it's thinking more concisely.
And this is crucial. This wasn't just about learning how to do math better. The underlying problem-solving skills the model developed actually transferred to other areas. After being trained only on math, it showed improved performance on scientific reasoning, even beating other specialized models on science benchmarks. What this tells us is that it learned how to reason, not just how to do one specific task. So, what does all of this mean for the bigger picture? What are the key things we should really take away from this incredible research?
Well, the paper's conclusion really boils down to 4 key insights. First, that efficiency can absolutely beat raw scale. Second, that this idea of agentic learning, teaching models to use tools, is a profoundly effective way to get to better reasoning. Third, that focusing on the quality of the process, not just a final answer, is absolutely critical. And finally, that these reasoning skills can generalize in really powerful ways.
In the end, the author's own words from the paper really summarize it best. They created a model that thinks smarter than merely longer, proving just how powerful this new agentic approach really is.
Which leaves us with a final, really thought-provoking question. Maybe the race for artificial general intelligence isn't a hardware race to build the biggest possible brain. Maybe it's actually a software and training challenge, to teach our models not just to know more, but to be fundamentally better, more efficient, and more resourceful problem solvers.
For more explainers that break down the cutting edge of AI research just like this one, make sure you subscribe to VibeDoc here on YouTube. Thanks so much for watching.